I'd like to introduce the idea of profit cost analysis and then give you several examples of this concept at work. Right, so this is another application of linear equations or linear functions, and we're using linear functions to describe the relationship between a company's cost for producing products and the revenue that they earn from selling the product. So we want to kind of compare these two dollar amounts and look at the idea of answering a couple key questions, which are the biggest concern for a company. They're interested in knowing when they'll be able to pay off those costs and start to make money. So in break-even analysis, we're looking at three different situations. We're looking at the situation in which cost is greater than the revenue earned, and this would be the situation in which the company is losing money. When cost is less than revenue, this is good, the company is making money. And then we have the one exact spot in between these two situations, when the cost exactly equals the revenue, then we would say that the company breaks even. So they're not making money, they're not losing money, but they have paid off all of those costs. All right, so remember that revenue is just the dollar amount that's being earned. It's not pure profit because it is going towards paying some of those costs. All right, so cost is the amount of money it costs to produce a product or a service. It's a cost to a company, something like supplies for producing a product, or maybe their rent that they pay on their building, something like that. Right, so we have different kinds of costs. We have fixed costs, and these would be the same for the company regardless of whether they produce 10 products or 1,000 products. So you might have an overhead charge or utilities, the rent of your building, setup costs, things like that. Variable costs would be the costs that do depend on the number of products produced. So if a company produces cake pans, then a variable cost would be the metal needed for the different cake pans. So the more you produce, the more of that metal you will need. Packaging would be a variable cost. If you sell more products, then you will need more packaging supplies for those products. Revenue is just the money earned from selling that product, and then profit would be revenue minus the cost. So after you've paid off all of those fixed and variable costs, the amount of money that's left is the profit. And then let's look at some examples. Example 1, right, this is from your book, Mathematical Ideas. Right, Peripheral Visions Incorporated produces studio quality DVDs of live concerts. The company places an ad in a trade newsletter. The cost of the ad is $100. Each DVD costs $20 to produce, and the company charges $24 per disc. Express the cost C as a function of X, the number of DVDs produced and sold. All right, so when we say cost can be expressed as a function of X, we mean that the cost is dependent on the value of X. And that makes sense. Right? The more DVDs you produce, the greater the cost will be. All right, and then here's a hint for you. Cost equals the variable cost times the number of items plus the fixed cost. All right, so in this case, the cost would be equal to whatever expenses are dependent on the number of DVDs, X, and then off to the side here we kind of just tack on this fixed cost that's independent of the number of DVDs produced. Alright, so let's look back through your example. We have a couple different costs. We have the cost of the ad, $100, and then we have the fact that each DVD costs $20 to produce. Okay. So the cost of the ad would be the same regardless of how many DVDs are produced. So that is your fixed cost. And then if each DVD costs $20 to produce, that's your variable cost. All right, so think about if you produced 4 DVDs, then you'd have $80 in cost to produce those. Whereas if you had 6 DVDs that were produced, then that would give you $120 worth of costs. All right, but that cost of the ad would still be $100 regardless. And then you have a final number here. The company charges $24 per disc. All right, so this is not a cost to the company. This is what they're charging people who are going to purchase these DVDs. All right, so part 2 here, express the revenue as a function of X, the number of DVDs sold. All right, so revenue, the total amount of money that's coming in, is however much is being charged for each item, $24, times the number of items sold. All right, so if you sell 1 DVD, the company brings in $24. If they sell 100 DVDs, they would bring in $2,400. And then we can use these two equations to answer this next question: when will the company break even? So we want to know for what value of X does the revenue equal the cost? Okay, when does R equal C? All right, so to set revenue equal to cost, we have two expressions here. We have 24X is the revenue, and we want to know when does that equal the cost, which is 20X plus 100. All right, and then from there, we just need to solve for X. So if you subtract 20X from both sides, right, that combines like terms, and we see that we have 4X equals 100, and divide both sides by 4, and we see that X equals 25. Right, so hopefully, if we did this correctly, the company's revenue and cost will be equal when they sell 25 DVDs. And we can check this just by substituting that value into the cost and revenue equations. Right, so the cost of producing 25 DVDs would be $20 for each DVD, plus that $100 fixed cost, right, and that would be 500 plus 100, or $600. And then their revenue earned from selling those 25 DVDs would be 24 times 25, right, substituting in 25 for the X, and then that also gives us $600. Right, so that's a way that you can check. Just substitute your answer back in for X in cost and revenue and see if they turn out to be the same. Graph the cost and revenue functions on the same coordinate system and interpret the graph. All right, and we have some questions that we can use to interpret the graph. So we'll get to that part next. But let's start with the graphing. All right, so I'll draw some axes here. All right, and on your worksheet I've given you some axes as well. And notice that for profit and cost, we're just talking about positive amounts of products being sold, positive cost, positive revenue. All right, so we don't need any of the other quadrants other than the one in which all of the variables and values are positive. Right, so that's why we only have one quadrant here. All right, so we have two functions to graph. We have cost, which was 20x plus 100. And we have revenue, which was 24x. And I'm actually going to go back. Let me make that an orange color here, so we can tell these two lines apart. All right, so we can see, hopefully you can see from these equations that these are going to be lines because they're in a linear format here. This is just y equals mx plus b. All right, so in your first equation we have, right, 20 is your slope, All right, and 100 is your intercept. All right, so if we start out, and I definitely can't fit 100 on this axis, so I would definitely need to use a scale for this, and let me try to choose this carefully. All right, so if you're trying to decide how to do this, basically just count the number of squares or units available, and it looks like I have 2, 4, 6, 8, 10, 12, 14, 16. I definitely don't have 20, so I might not want to go by 5s. Maybe I'll go by 10s here. Alright, so I'll let each line represent 10. And you don't have to label all of these, just one or two to kind of give the right idea here that we're going up by 10s. Alright, and then on the x-axis, alright, if I keep in mind my DVDs, my break-even point is when I've sold 25 DVDs. So I don't really need to go very high for these. I might be able to fit these by 1s, but I think I'll do 2s just to make sure that I can fit this in. Right, and you may need to kind of adjust or play with these numbers on your own and just choose something that works. Alright, so I'll go by a scale of 2s on the x-axis. Alright, so my first line for cost, I have an intercept of 100, so 10, 20, 100 would be here. Alright, and then my slope is 20, so I'm going up basically 2 squares every time. This is 20 over 1. Every time my x increases by 1 unit. So I would go half a square to the right and up 2. Alright, to show an increase of 20 units for the y and 1 unit for the x. Alright, and then I would go up another 20 units by the time I'm increased to 2 units of x. Alright, and then I would continue increasing my x by 1 and my y value by 20. Alright, and that looks like that's all I can fit on this graph. Alright, and if you notice at this point, this does look a little squished, and I wanted you to see what something like this would look like. So it might work for me to kind of spread out that x-axis, because it looks like my line's going up very sharply, and I'm probably not going to be able to see what this looks like by the time I get to an x value of 25. Alright, and notice my other issue here. What I'm hoping to do is to be able to see the break-even point, and I can see from here, for my solution, that my break-even point is 25,600. So the way I've drawn the graph now, there's definitely no way I'm going to be able to see that on the graph, since my y-axis 600 kind of runs off the page. So you may need to kind of adjust these scales as you go, and you can try to take a guess ahead of time which numbers are going to work, but sometimes it doesn't always work. Alright, so let's rethink these numbers. Alright, so let's see. I need to get up to 600 on my y-axis, and I didn't even have quite 20 lines. I may have 15 here. 6, 8, 10, 12, 14. Yeah, I have 15 or 16 lines. So maybe I could go up by 40s instead. Okay. Etc. Going up by 40s. And then on my x-axis, let's see, I may want to spread these out as well. Yeah, let's go by 2s again. We'll keep the 2s. Alright, so let's try this. Alright, so we still have an intercept of 100, and now I'll kind of have to estimate where that is on my axis. Alright, since I have 80 and 120, I'm kind of between there. Alright, exactly halfway actually, so that would be about here. Alright, and then I still am going over 1 and up 20. Alright, so I would go over 1, up 20. Whoops. Over 1, up 20. Over 1, up 20. And you can kind of get the idea there. Alright. And once you have enough points to kind of give you a feel for this, right, you can just draw in a line. The other thing you can do is just check and make sure that at least that break-even point is represented. Alright, so let me see how close I was. 25 if I'm going by 2s. Let me count that out. Alright, so I've gone and labeled some of these axes, and here's my point 25 on the x-axis, and if I follow that up, not quite at 600, but fairly close. Right, but I know that that's a point on the line. Alright, so I can kind of shift my line a little bit here to more accurately reflect that point. And there we go. Alright, close enough. Okay, so there's the break-even point. Now revenue equals 24x, and if I'm using slope-intercept form, notice that this is plus 0, right? So I'm starting out with a y-intercept of 0, and then I know for sure that the point 25, 600 is on that line, so I can cheat a little and almost just use that as a second point, right? And I don't really need any other points in between, but if I was looking at the slope, I would need to move over 1 unit to the right and 24 units up to keep finding additional points. All right, so you can kind of throw in another point there if you wanted to see 1 unit over, 24 units up. Oops. All right, and we definitely wouldn't even be to 40 yet, so we're kind of squished in there. 1 unit over, 24 up, etc., etc. All right, so let's try to connect. We'll try to connect those 2 points at least. Alright, and then there we go. Alright, so that would represent, the orange line would represent the revenue. Alright, so from this graph, hopefully if you graph this correctly, you should see a couple key things. First of all, your revenue should always start at the origin, at 0, 0, because if you sell 0 products, then you'll make $0. Your costs, on the other hand, will not start at 0, 0 as long as there's some sort of a fixed cost. And then the other thing you're looking for is to see, is there a break-even point? And then notice at some point that the revenue starts to exceed the cost. And that's what the company would like to see over time, that they would break even, and then at some point that the costs would be lower than the revenue so that they start to make a profit. Alright, so we can interpret this graph with a few questions. At the break-even point, how many items are sold? Right, so your X value, that's going to be the number of items sold. So in this case it was 25 DVDs. And then what is the cost and the revenue at that point? Alright, so that's a single number. And at that point, both the cost and the revenue are $600. When will the company lose money? They'll lose money if they sell less than 25 DVDs. Sell fewer than 25 DVDs. What is the minimum number of items that needs to be sold in order for the company to make a profit? Alright, so this one worked out nicely. Your break-even point happens to be a whole number, but sometimes you'll end up with some sort of a fraction or a decimal. And so if you can't sell a portion of a product, if you can only sell whole products, then you would just kind of bump it up to the next whole number. Right? So in this case, the minimum number of items needed to be sold to make a profit, right, would be 26 DVDs. Right? Because they're not making a profit at 25 DVDs. They've just broken even. So profit occurs as soon as they get to the next number of units that can be sold beyond that.